All right, young scholars. Last class we reviewed basic Java concepts such as creating classes, methods, and objects. Today I want to focus on reviewing control statements, some more on methods, classes, and objects, and arrays. Now these slide decks I'm going to go through today: control statements, methods, a deeper look; arrays and array lists; classes and objects, a deeper look.
Nothing, bro.
All within the first folder on our Blackboard course page. So I'm going to go through that today, and then in class on Wednesday, I'm going to give an introduction to Android Studio, and then next week we'll get started and start building our apps. So first, let's start with control statements here. Now everybody knows what a control statement is, right? If else, switch, etc.
Yes.
Okay, good. So when writing them, or any Java program, I like to use what is called pseudocode. It's also represented here in these slides and recommended, where you write out code, not always in comments, but I tend to do them in comments and fix up your code as necessary. The way the author recommends pseudocode being explained is that you're basically writing it out in English before you write it out in Java. So there are three main types of selection statements: an if statement, an if-else statement, and a switch statement. With an if statement, there's only one condition. If it's true, then the code is run. If it's false, nothing happens. With an if-else statement, there's two kinds of conditions. If it's true, the if statement runs. If it's false, the else statement runs. So for example, an if statement: if I'm hungry, I'm going to eat food. Okay? An if-else statement: if I'm hungry, I'm going to look in the fridge. Otherwise, there's no food, I may not eat. Then with a switch statement, you could have multiple different opportunities. It's not just true or false. It could be case 1, case 2, case 3, case 4. There's also three repetition statements or looping statements: while, for, and do while. While and for loops will check a condition before running, and a do while loop just runs without checking anything. So the remaining slides within this Appendix C documentation I provided you in last week's, or the first week of class folder, just goes through example code and reasons for when you might use some of these codes for a control statement. You'll notice they're labeled as case study. Some code may be split off into, yes, these are on Blackboard already in the, I think it says 928, 930 introduction, of course, the first folder in Blackboard. So I just went through control statements. Next, I'm going to focus on methods So if you look in our Blackboard shell, these are in that first folder, introductory course content for 828 and 830. Right after the intro to Java and intro to classes, objects, methods, and strings that we covered last week. So we're going to go through, we just went through control statements, then we're going to do methods, a deeper look, then arrays and array lists, then classes and objects, and the other appendi from this course textbook that I decided to use that you guys don't need to get because I've posted everything up for you. Those you can all review as you so choose. You may or may not have learned that programming, such as inheritance in Programming 1. Some of those concepts are more along the lines of Programming 2. However, you need to have some basis of Java programming background in order to use Android Studio, which is why I'm going through some of these basic concepts as a review before we jump into everything next week. So next I want to go through methods, a deeper look. And focus on the math class methods. Everybody remembers how to import classes or packages in Java? Dwayne, how would you import a Java class?
I think you say import, you gotta use the import thing first and then you,
Yep, you import whatever it may be, the scanner class, the math
yes,
class, the number format class, whatever you need to use, you have to do it before your creation of your class and methods within your code. And within the math class, there's absolute value. You can use ceiling, cosine, exponential. You can create a floor. You can conduct a logarithm, find the max between two values, the min between two values, the power between two values, though technically you can find them beyond more than two. Those are just the examples provided here. You can find the sine of a number, the square root of a number, the tangent of a number. So as you hopefully learned within Programming 1, there are a lot of classes that are already pre-made where you can import them and use all of the available methods within them. So in this example, we have math_pi, putting out pi for us, just certain numbers. So I reviewed this in my Programming 2 class. I'm hoping all of you guys knew this as well, that any value you label as final is constant and cannot be changed. You all learned that in Programming 1, hopefully?
yes.
Yes, good, okay. So if you were to set something as a final int, it does not change. So on slide 16 here, we have in row 21, a fairly uncommon way to set up a method. Here on slide 17, this is a more common way you'll see a method defined. Public, static, double, maximum is the name of your method, and then your variables that you have inputted here. So it's X, Y, and Z as a double. So everybody sees how that is kind of more obvious to a user that's going to view your code, as opposed to on slide 16 here, line 21, double result equals maximum. In essence, it's doing the same thing. However, setting it up so it's a clear method to anybody who looks at it is probably the best way to write your code. Because as I said, the way I do it and the way most suggest doing it is with the pseudocode where you're writing out the comments. So you can clearly comment at the top of this method what it's doing. So in your previous Programming 1 courses, did your professors require comments at all?
No.
No.
No, we didn't require comments.
Okay. So like I said during our first meeting last Wednesday, I don't care for the when you do your mini app 1, your mini app 2, your mini app 3, but when you do the group project, just so I know who did what section, just put like a little comment. Let's say Dwayne, Chris, and Brian are one group. Just say in your Java comments, okay, this is the third of the app that Dwayne did. This is the third of the app that Chris did. This is the third of the app that Brian did. So that would be the only instance in which I care that you use your Java comments. So as I mentioned earlier, there may be a need where you need to import a class. This makes it easier for you to do so you don't have to create a class yourself. So don't you think it's much easier, like if you need to do a multiplication where you can use the math class and just, okay, it's done for me, as opposed to creating your class to invent a multiplication? Or for example, has anybody even had like an advanced math course where they use sine or cosine?
Yeah,
Yeah.
calculus.
Yeah,
Calculus? Okay. So you've seen it before in calculus, but wouldn't you prefer using the class that's already created, cosine, instead of creating your own class to create a cosine?
Yeah, I would prefer to use something I already had.
Right. Makes it much easier. You don't have to do the work. It's already done for you. You just import it and use what you need to use. So all of the Java API documentation or classes that are available to you should be listed on this Java API documentation link provided on slide 34. There's also, if you Google them, multiple lists. I believe Wikipedia even has a semi-full list of all the Java API packages or imported classes you can create. Here's some examples to create an event, the input-output package, the language package. Why would you want to use the language package? Who hasn't spoken yet? Felix, why would you want to use the language package?
Are you like,
Why would you want to use the Java language package? Import that class to use it. What kind of instance?
um,
What if you speak multiple languages? What if you speak both English and Spanish, and you have a user that comes along that only speaks Spanish? You could ask them, hey, do you want to, run this code in English or Spanish? And they could answer Spanish, and then it would spit out any output that you might need them to respond to in Spanish instead of English. So the remaining slides here, as you go through them, same as before, they provide example code and ways in which you might want to utilize methods. So on slide 44, as an example, here we're importing the random class. in order to simulate rather, the dice game craps, which requires you to throw dice, and then gives you 5 slides of Java code on how you would create a dice game. If you're to import certain graphics classes, you can even go ahead and create actual dice and have them display on your screen. But that's kind of beyond what we're going to introduce here. Because like I said, with Android Studio, we just need to understand, hey, how do we create classes? How do we create methods? How do we import certain things? So next I will touch on arrays and array lists. Now, I believe there's 2 of you that are also in my Programming 2 classes. In our review in class this week, we're going to focus on arrays as well. So you'll see this again tomorrow and Thursday. So who knows what an array is? Anybody remember? Nobody?
Isn't it like a group of values?
Yep. So arrays are commonly used in math and Java to organize or index info in order to retrieve or display them. So the inputs within an array are called elements. The elements end up indexed. So how many elements do we have in this array? It should be
12.
obvious. It does it on the screen.
12?
This is a 12 element array. And the index goes from 0 through 11. So if you have a 12 element array, the index starts at 0 and goes through 11. If you have a 5 element array, the index will start at 0 and go to 4. If you have an 8 element array, the index will start at 0 and go to 7. So what is this example code doing here? Int bracket bracket C equals new int bracket 12 bracket semicolon. What does that line of code do?
It's creating a 13 array code.
It's creating an array with, I think like 11, not 12, but like the 0 takes 1 space or something.
Yep. So we're creating an array called C, which only accepts integer values. There's going to be 12 integer values. So that means 12 elements. But the index will be 0 through 11. So instead of 1 through 12, it's 0 through 11. The index will start at 0. So hopefully, as you saw in Programming 1, you could write this creation of an array either using 1 line of code or using 2 lines of code. Now me, I would tend to use the 1 line of code. However, I'd probably have the comments either right before it or right after it, indicating that I'm declaring an array variable, creating an array with 12 inputs. So what happened when you set up an array like this?
A typical array, you really gotta set up a for loop to start adding variable. Array list, I think you just do like array dot add, and then you can start adding variables.
Right.
Arrays.
So in this instance, we can either use a for loop to just randomly create our 12 elements, or you can use the scanner class to have individuals input that. Now, as my programming 2 class will see this week, we can also use arrays that have strings. So for example, their homework later this week is to create an array that prints out all of their students in their class. So how would I change this line of code so that we had 7 strings?
Instead of int, would you just put string?
Yep. So it would be string bracket bracket. Let's say class equals new string. And then instead of 12, it would be 7.
So it would go from 0 to 6, right?
Yep. The index would be 0 to 6 because there would be 7 students. And here on slide 18 is another example of that. Arrays can be set to have randomized elements, or in this example, user-created elements. So we have 10, 20, 30, 40, 50. So that means there's 5 elements, and the index would be from 0 to 4. The index is always whatever number of elements you have minus 1. So if you have 5 elements, the last index is 4. If you have 10 elements, the last index is 9. If you have 22 elements, the last index is 21, etc. So like I said, you could either do it using a for loop, where the information is automatically created for you. You could do it this way, where you as the programmer put in the information within the array already, or you could use the scanner class in order to get the information from the user. So here's another example where you, as the programmer, are setting up the values for your array by yourself, 32, 27, 64, etc. And again, the remaining slides provide example code and ways in which you would use your methods, your arrays, examples of why you might use them. Again, we go back to the possible roll dice example. The most common way you think of arrays would be what? What have you seen many, many years ago as a student in your classes that you would think an array would be most associated with? Maybe first grade, second grade, third grade.
You said what would we think array would be associated with?
Yes. Like
Is
you
it grades?
you learned it very early in math.
I think
Is it
like a score
grades?
drawer or something. Like, is that what you mean?
Like a multiplication table. You remember
Oh,
your 1 times 1 is 1, 2 times 2 is 4, 3 times
oh,
3
okay,
is
yeah, I see,
9.
I see.
Now that would be tied more to a 2-dimensional array. Let's see if we have any examples. So this might be considered a 2-dimensional array here. You have 2 separate arrays working together. So on slide 82 here, this example is a 2-dimensional array with 3 rows and 4 columns. So it would probably look something like this when you're setting it up. A 3x4 array. Brian, question? Multiplication tables is in 4th grade now. Okay. I'm much, much older than all of you, so as I'm sure you gathered. So again, like I indicated, the rest of the slide is other examples of code. Here's another example of how you would write out a multiple or a multi-dimensional array. In this example, it is 2D. You can have more than 2 dimensions, obviously, by the object of multiple dimension, but usually you'll have 1 or 2 dimensions for an array. And these last few slides go over how to sort an array using the sort class. Okay, now last but not least, I'm going to focus on classes and objects, a deeper look. So you all know how to create a class. Very simple, right? What are we doing on line 4 in slide 6 here?
Creating a private integer.
On line 4, public class.
I was looking at 6. You're creating a class.
Yep, we're just creating our class and we're calling it time1. And then on line 12, we're creating our method. Line 6 through 8, we're setting our variables that we're using, our parameters. So the private, what does the private mean? Dwayne?
I mean, I think private is set to the within the class.
Yep. Private means we can only use it within the class. So if we go and we create public class time2, we have to create these integers or these parameters over again. What are we doing on lines 28 and 34 here? Creating 2 more methods. In this instance, public string to universal string, public string to string. What are we doing here on line 9? Time1 time equals new time 1.
That constructor.
Yeah, what's another name for constructor? It's right on the line above it in our comment. Yep, constructing an object. And then we go and use it here in slides, line 13, 15, 19, 21, 23. And then we use it again in lines 29, 39, and 41 in the next slides. So the remaining slides again provide more example code and situations where you might use inherited classes and methods and objects all together. But remember, if you don't import a class correctly, you can't use it. So for example, if you wanted to import the scanner class, if you just said import Java scanner, that's not going to work for you. You would need to use your regular Java syntax for it to work properly. Okay, so as I mentioned, on Wednesday, you guys will be introduced to using Android Studio. I'll go over some basic information on it, and then next week we'll start actually using Android Studio. Again, all of these slide decks are in the first folder, introductory course content for 828 and 830, because if you'll recall, they didn't set up my account for Bloomfield until like 5 minutes before we were supposed to have class that first day, so I gave you a break the first week. So again, keep in mind that you are more than welcome to complete homeworks 2 through 6 right now, whenever you want to do them. I think Kesney already did all of them. Awesome job. Like I said, they're only focused on basically asking your opinions on how you use apps. So they're simple 3 to 5 sentence responses to them, so you can get them all done and out of the way, so you could focus on the only 4 other things you have to do for the class, the 3 mini apps and the group projects. Also, think about your potential group members. So we have 9 young scholars in the class. Like I said, perhaps you guys could do 3 groups of 3. Actually, since we have some time here, why don't we put in the chat, let's say, give your opinion of your Java skills on a scale of 1 to 5. And everybody could just type in there. If you're great with Java, go ahead and give yourself a 5. I think one of you indicated on the intro post that you've done game programming, so you might be more advanced than the others. Now, do any of you know each other from other classes you've had together? Okay, so
Yeah, some of us.
Yeah.
everybody seems to be on the same 3 to 3.5 level, which is perfectly fine. I was kind of thinking that there might be 1 or 2 that might be more advanced, but that's fine. So everybody's in that 3 range. Okay, so like I said, since we have 9 young scholars, let's go with 3 groups of 3 and think about who you'd want in your group. So like I gave the example, maybe Dwayne, Brian, and Chris might be a group together. I could care less what the groups are. You can go ahead and set them up. Let's say Dwayne, Brian, and Chris already know each other from other classes. The only reason I'd like you to create it within the next week or so and let me know is because on Blackboard I could set it up where you have your own group section. However, I recognize these days the young scholars tend to just talk to each other through a group chat. That's perfectly fine too. So if there's no questions on that, I will see all of you on Wednesday. And like I said, we'll go through an introduction to Android Studio basics. So your homework for this week is to do homework 1. It'll be due on Sunday. Download Android Studio and the Java components if you haven't done that already. That is in the Before You Begin file here in the introductory course content for 828 and 830. And try to set up your groups if possible. Like I said, you could let me know via email, and I can set up on Blackboard here a little section for you guys to interact. But like I said, I understand these days that all of you tend to go more towards a group chat, which especially for a mobile apps class is completely fine. So if there's no questions, I bid all of you adieu, and I will see you on Wednesday. Going forward, I'm just going to place the Zoom link up on Blackboard. So like I had here, today's Zoom meeting, all the info is in there. For Wednesday, I'll just put 9:13 Zoom meeting with all the info in that page right on Blackboard, rather than put it on Blackboard and then also send you an email about it. Since all of you are already coming anyway, I think it defeats kind of the purpose for doing it both ways. All right, if there's no questions, I will see all of you on Wednesday.
All right. Thank you, Professor. Have a
See
great
you
day.
Wednesday.
Take care.